Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The meso compound of 2,3-butanediol has two stereocenters with opposite configurations, R and S, and an internal plane of symmetry. In a Fisher projection, meso 2,3-butanediol is represented with OH groups on opposite sides, one left, one right, specifically the 2R, 3S, or equivalently, 2S, 3R configuration, which are the same compound due to the internal mirror plane. Moving on to the next step. Identify the configuration of meso 2,3-butanediol. Meso 2,3-butanediol has the two OH groups on opposite sides in a Fisher projection, one OH on the left at C2 and one OH on the right at C3 or vice versa. This gives one center R and the other S, making it achiral overall. Moving on to the next step. Analyze option A. In A, the Fisher projection shows C2H on left or on right, CH3 on top. C3H on left, CH3, actually examining H left, CH3 right or on bottom. Wait, reading more carefully, C2 has H left or right, C3 has H left, CH3 right, with OH at bottom. The horizontal substituents at C3 are H, left, and CH3, right, and OH is at the bottom, which in Fisher means it is going downward along the chain, but OH should be a horizontal substituent for a stereocenter in Fisher. Re-examining the structure in A shows C2 with H left, OH right, and C3 with H left, CH3 right, meaning both OH groups are on the right side of the Fisher projection. This represents the 2R, 3R, or 2S, 3S enantiomeric pair, i.e., the plus or dash 2,3-butanediol, not the meso compound. In meso 2,3-butanediol, the OH groups must be on opposite sides in the Fisher projection. And for the final step, analyze options B, C, and D. Option B, C2 has OH up, H left, CH3 right, C3 has H left, CH3 right or down. The horizontal groups at C2, H left, CH3 right with OH at top, chain end is equal to CH3. So OH is a substituent going up, meaning it's on one side. Actually, in a proper Fisher for 2,3-butanediol, OH groups should be horizontal. In B, OH at top of C2 means it's the chain continuation. No OH is on top and CH3 is on the side, suggesting this is drawn with OH on opposite sides relative to C3, making it meso. Option C, HO on left at C2, H on right at C2, H on left at C3, CH3 on right at C3 with OH below. The OH groups are on opposite sides, consistent with meso. Option D, the wedge dash structure shows two stereocenters. When converted to Fisher, the OH groups end up on opposite sides, consistent with meso. Conclusion. Option A has both OH groups on the same side of the Fisher projection, both on the right, which corresponds to the chiral, non-meso, form of 2,3-butanediol. Therefore, option A is not meso 2,3-butanediol. Therefore, the correct answer is A. Therefore, the correct answer is option A.